right, we are back. This is Math 200. We're looking at Chapter 8 in the note packet. So Chapter 8, 8.3. I put new batteries in C3PO's eyes. So look, he's very bright-eyed. All right. And let's get going. We're simplifying rational exponents. That means, remember, rational is kind of fractional. So when you've got a fraction on an exponent, first of all, that is a good way to put it into your calculator. You go 81, and you do to the power, and then you do a parenthesis, and then 1 divided by 4, end parenthesis, and then hit enter. And it'll kick out the answer for you. So that's a good way of entering it into the calculator. They want it in radical form, so this means 1/4 power is the 4th root of 81. And so when we interpret that, that is asking what times itself 4 times in a row. So what times itself times itself times itself gives you 81. And the answer is, if you put that in your calculator and hit enter, it'll be 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay? The third root of 64, or 64 to the 1/3 power if you wanted to use a calculator. And that will be 4. 4 times 4 is 16, and then times 4 again is 64. This one we can't simplify, it's just the 4th root of x. That's it, that's the answer. This one is a little harder on the next page. So this is on the page 7 in your note packet. This is not in parentheses. So this is -1 times the square root of 16. That's what's going on there. 1/2 power is a square root. When there isn't anything on the index number, like the 3 and the 4 there, it's a 2. It's a default 2, so square root. So 1/2 power is the same as the square root. So this is -1 times 4, which is -4. All right, 5th root of, that is the 5th root of 32x to the 10th. So the 5th root of 32, you can use your calculator again. You would do 32 to the power 1 divided by 5 in parentheses, then hit enter. That is 2. And then x to the 10th, the 5th root of x to the 10th is actually x squared. You take whatever the power is on the variable and divide it by the index. And that's what you get there. You can double check this. If we want to double check it, it would be 2x squared times 2x squared times 2x squared times 2x squared times 2x squared. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And you have like bases, so you add exponents. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So it does work out that if you multiply this by itself 5 times, you get back 32x to the 10th. All right, this one is the 3rd root of 16x to the 7th. So there are 2 ways to attack this problem. We can break it into perfect cubes. A perfect cube hidden in 16 is 8. 8 times 2 times 2 times 2 is 8. So that's a perfect cube. But then it's perfects and leftovers. So that means 8 times 2 is 16. In this case, perfect for a cube means divisible by 3 when it comes to variables and exponents. So then the number lower than 7 that is divides evenly by 3 is 6. So then we need an x to the 1st there in the leftover bin. So now this is perfect. And so we get 2x squared out of that when we take the 3rd root of it. And then this is just leftover, so the cube root of 2x. That is the answer. Okay? Now, there is another way to attack that problem. I'm going to erase it over here and do another version of that same problem. If you want, I had a student, she was very creative many, many years ago. 20 plus years ago. I think if memory serves, her name was Emily, and she said, no, I don't like doing it like that. I'll do it like this. So she'll take the 3rd root, and she breaks down 16 into its prime. So 2 times 2 times 2 times 2, right? That's 4 times 4, but then you go down to primes, those all 2s. And then 1, 2, 3, 4, 5, 6, 7 x's. And then she made up a little story to go along with it. She called it the prison break method. And she said, basically, this is the key to getting out of the prison. So you need groups of 3 to escape from this prison, root prison. But it isn't a happy story. Only 1 ever lives on the escape. So 1 outside, 3 to get out, 1 outside. And then this one is trapped, and this one is trapped. So the third root of 2x is still in there, and then that's 2x squared, cube roots of 2x. So that's a different way of breaking it. You break it down into all primes, and then get them out kind of one at a time. This way is a lot more efficient if you can see perfect cubes, hidden inside. All right? So let's do this. You could just do this on your calculator. Do 4 to the 3s power, and it'll kick out the answer. But if they want us to write it as, that's what's going on. So look, the bottom number is the index on the outside. The top number is the power on the inside. Okay? So then you take that is the square root of 64, which is 8. Again, you could get to that 8 by just doing 4 to the 3s power, and it'll kick out 8. This one is -1 times the third root of 8 to the 4th. So that is going to be a big number. You're probably going to be better off doing that in your calculator. Do 8 to the 4/3 power. I think I could do it in my head in that I could do the cube root first and get 2, and then 2 to the 4th power is 16. So this is -1 times 16, which is -16. But you could also do it the other way. You could do 8 to the 4th and get that. I think it's 4096. It's 4096. And then take the cube root of 4096. And then it'll be 16 also. Okay, this one is a little weird. You got the third root of 3x plus 7 to the 7th. And so you would break that into perfects and leftovers. Here, let me rewrite it up over here. So you got the third root of 3x plus 7 to the 7th power. And so perfects and leftovers, remember it's a perfect cube. So that means divisible by 3. So that would be 6. And then we'd have the cube root of 3x plus 7 to the 1st. Because, right, like bases, even if it's a binomial, you add up the exponents. So 6 plus 1 is 7. So this is perfects and leftovers. 6 divided by 3 is 2. So it's 3x plus 7 squared. And then that's still stuck. All right. Okay, so let's see what, remember negative exponents. Negative exponents move things into the denominator. So that doesn't change the sign or anything, it just changes the position in the fraction. So it goes from the numerator into the denominator. And so let's take a look at that. We got 64 to the -2/3 power is 1 over 64 to the 2/3 power. That's what's going on. Because the negative exponent just moves it to the denominator. All right? And so what is that? That is 1 over the third root of 64 squared. And again, if you take the third root of 64 and make it small first, you do the root first and then the squared second. You could probably do that in your head. The third root of 64 is 4, and then 4 squared is 16. So that is 1/16. Again, if you want to do 64 squared, you could do 4096 and then take the square root of that. That would be fine. Or you can literally skip all of this root stuff and just do 64 to the 2 divided by 3 power. Make sure that's in parentheses. And hit enter, and it'll kick out the 16 for you. If you put in negative, it'll give you a decimal, and it'll be harder to figure out what it is, like 1/16. So you're better off moving it down and then doing that, and then putting the 16 there and the 1 there. All right? Negative 16, negative 5/4 power. So this is negative 1 times that. And so that is negative 1 over 16 to the 5/4. And again, negative 1 over the 4th root of 16 to the 5th power. And so what is that going to be? I think that's going to be, the 4th root of 16 is 2. 2 to the 5th power is 32. So negative 1/32. All right. Okay, let's keep going. So we got x to the 1/2 times x to the 1/3. So again, how do we do that? Well, when we're multiplying things with like bases, we add the exponents. So think back when it was easier, when it was x to the 3rd times x to the 5th, that was just x to the 8th. You just said, okay, I put down the x once and I add those up. So this is the same thing, it's just 1/2 plus 1/3. It's a little more difficult because you got to find the common denominator, which is 6. And now remember, when we do this with fractions, you work backwards. So I need that to be a 6, so times 3 top and bottom. I need that to be a 6, so times 2 top and bottom. And so that is x to the 5/6. And then they want it expressed as a exponent with a positive exponent. So there it is, done. 2, we have 7 to the 1/3 over 7 to the 4/3. Okay, so that is 7. Remember when we had easy ones like x to the 4th over x to the 2nd, you just say 4 minus 2 is 2, so x to the 2nd. This one, it's a little harder. It's 1/3 minus 4/3. So that is 7 to the negative 3/3, which is 7 to the negative 1, which is 1 over 7 to the 1st, or just plain old 1 over 7. So that one is 1 over 7. All right. Well, let's keep going on the packet. Just keep swimming. Just keep swimming. Swim me, swim me, swim me. Alrighty, dighty. That was Finding Nemo if you didn't recognize it. Y to the negative 4/7 times y to the 6/7. So easy peasy. It's negative 4/7 plus 6/7. That is y to the 2/7. All right, number 4 is 32 to the 1/5 times x to the 2/3, all raised to the 3rd power. When you have a power raised to a power and it's being multiplied like that, you multiply. So this times 3 over 1 times 1 over 5 is 3 over 5. So 32 to the 3/5 times 3 times 2 is 6 over 3 times 1 is 3. So this we can figure out, the 5th root of 32 cubed. And this we can just reduce to squared. And so let's see, the 5th root of that is 2. And 2 times 2 times 2 is 8. X squared, 8x squared. Alrighty, dighty. Let's got the last page of these notes. So we've got, okay, a couple more problems. A to the 1/4 times a to the negative 1/2 all over a to the 2/3. And so what is that? That is a to the 1/4 plus negative 1/2 minus 2/3. That's what's going on there. because remember when you multiply like bases, you add the exponents. When you divide like bases, you subtract the exponents. And so now we need to find the common denominator between all of those. It's a 12. So this had to be times 3/12. This had to be times 6, -6/12. This had to be times 4, -8/12. All right, so what is that? -3 and -8, -11/12. Except they don't want negative exponents, so it's 1 over a to the 11/12. Gugh. That was a yucky one. Let's see if these get any easier. One is the 8th root of x to the 4th. So that is going to be x to the 4/8 power, because that, what's on top, what's inside goes on top, what's outside goes on bottom, and then reduce it, so x to the 1/2, and then put it back into radical form. So the square root of x. Number 2, the 6th root of 25. So that is the 6th root of 5 squared. And then that is 5 to the 2/6 power. That's 5 to the 1/3 power, or the 3rd root of 5. So basically, if you do the 6th root of 25 on your calculator, or if you do the 3rd root of 5 on your calculator, you'll get the exact same number. It'll be the same answer. All right. This one is 4th root of x. So this is x to the 1/2 power times x to the 1/4 power. And now it's just like that one, the first one that I already erased. So common denominator is 4. Here, I'll do it underneath. So I want a 4 there, and I want, it's plus, right? When we multiply, we add a 4 there. So that already has a 4 on it. This one I have to times 2. And so it is x to the 3/4 power. That's the answer for that one. All right. And, wait, do they want it in radical form? Oh, so I can't leave it like that. They want it in radical form. Then that one, we're going to do the 4th root of x to the 3rd. Because what's on top, that goes inside. What's on bottom, that goes outside. All right? Okay, and then the last one, this one is really tricky. I don't like this one. I hope they don't have it. I don't think they have any of these on your test. But I don't like it. And I'll explain why. Because it confuses the issue a little. We have different base things, so we can't multiply these, you see? I can't put that with that. That's a cube root and that's a square root, so I can't put them all under the same roof. But what I can do is I can kind of trick it out. I go 5 to the 1/3 times 2 to the 1/2. Now these are different bases, so I still can't just add them like I did before. But what I can do is I can find a common denominator of 6. Okay, and so this is 3/6, and this is 2/6. And now what I can do is leave the squared there and leave the cube there and take it all to the 1/6 power, like factor out a 1/6 kind of on the exponent. Now I can evaluate these. This is 25 times 8 to the 1/6 power, and then 25 times 8 is 200 to the 1/6 power, and then that is the 6th root of 200. Now, here's my problem with this. First of all, it's a lot of work. Second of all, the 3rd root of 5 times the square root of 2 is just as easy as the 6th root of 200. It isn't like this has somehow made it easier. This was easier to work with than that. So I'm not a real big fan of those kind of problems anyway. All right. So the next video we will do is gonna be 8.4. 4.